Think about the last time you experienced turbulence on a plane. Now think about it being 10 times worse. Imagine being strapped into a C-130, propellers buzzing, engines at full blast, with you and everything around you violently tossed around by extreme turbulence. Seconds feel like minutes, minutes feel like hours. Like being on a roller coaster. With each drop, you catch yourself holding your breath. Each time you slam into your seat, you grit your teeth, and then, right after the worst of the shaking, it happens. You break through the curtain of white cloud, and everything stops. Calm. Silence. Except for the hum of the plane's engines. And there you are, inside the eye of a hurricane, surrounded by a perfectly circular wall of white clouds. Clear skies above, deadly seas below. Contained by a wall of the most intense near-surface winds on Earth, sloping outward with height, so the eye widens the higher you go. This is nature's football stadium, sculpted by the wind, carved out of the clouds, shrouded in mystery. A monument to forces that exist beyond human control, even in this age of technological primacy. It is the epitome of the untamed skies. Beautiful, humbling, terrifying. In this moment, you are in Mother Nature's forbidden lair, a vertical cylinder of calm surrounded by some of the most violent winds that the Earth can conjure, isolated from the outside world. In the words of Alexander Hamilton on September 6, 1772, the hurricane, quote, raged very violently till 10 o'clock, then ensued a sudden and unexpected interval, which lasted about an hour, end quote. Hamilton had experienced the eye of a hurricane on the island of St. Croix, and after that quiet hour he continued, writing that the winds on the other side of the eye, quote, returned with redoubled fury and continued so till near 3 o'clock in the morning. Good God, what horror and destruction! It's impossible for me to describe or you to form any idea of it. It seemed as if a total dissolution of nature was taking place, end quote. Hamilton's first-hand encounter with the hurricane motivated his many writings and ultimately inspired him to seek a new life in the American colonies. And the rest is history. Few humans have experienced the inside of a hurricane's eye on land. Across the centuries, mariners who have been caught in the grips of the inside of a hurricane's eye have rarely lived to tell the tale. And yet, through the advance of meteorological science and the technology of aviation, we now regularly fly aircraft reconnaissance missions into the inner core of even the most intense hurricanes to collect much needed data, which at present cannot be done via satellites or other remote sensing techniques with equivalent accuracy. The Air Force Reserve's 53rd Weather Reconnaissance Squadron operates C-130s, while the National Oceanic and Atmospheric Administration operates P-3s. Both units are often referred to as the Hurricane Hunters, who alternate in flying missions into tropical disturbances, tropical storms, and hurricanes to feed crucial data to forecasters at the National Hurricane Center. Thanks to the invaluable data collected by the Hurricane Hunters over the decades, we have learned much about the structure of a hurricane, especially what goes on inside the forbidden eye of the storm, where even birds have been trapped and unable to leave until the hurricane dissipates over some distant landmass. So why is the eye of a hurricane shaped like a football stadium? Why does the eye wall of clouds containing the most intense winds slope outward with height like a large bowl? Well, this is due to the combination of two factors. Number one, the thermal wind relation, and number two, the conservation of angular momentum. The thermal wind relation is one of the natural laws in meteorology that dictates how winds behave when in the presence of some horizontal temperature gradient. We'll do a deep dive into the thermal wind relation in a future video, but for now, suffice it to say that within the context of a hurricane, the thermal wind relation states that when a storm is warm core, or warm on the inside, like in a hurricane, winds have to be cyclonic near the surface, and then switch to anticyclonic aloft. For hurricanes in the northern hemisphere, that means winds have to circulate counterclockwise near the surface, and then switch to clockwise near the top of the storm. Now, let's combine this thermal wind relation with the second factor, the conservation of angular momentum, which describes how a figure skater spins faster when she draws her arms in, or spins slower when she throws her arms out. Because the thermal wind relation dictates that counterclockwise winds near the surface must switch to clockwise winds as you go up inside a hurricane, that necessarily means that the winds must slow down as you go up from the surface before switching direction. In order to conserve angular momentum, this slowing of the winds means that the radius of the rotation, just like the arms of that figure skater, must necessarily increase or move outwards to compensate. This is why the clouds that form the eye wall of the hurricane slope outwards with height, creating Mother Nature's football stadium. You can see this clearly in that Hurricane Hunter video from inside the eye of Hurricane Melissa before it made landfall in Jamaica. The outward slope of the clouds can be seen, along with the diagonal cloud streaks along the inner edge of the eye wall that show how the circulation changes direction with height. In a future video, we will dive into the structure of the other parts of a hurricane, from the spiral rain bands lens to the different types of wind balances that are present in each vertical slice of the storm. Let me know in the comments below what topics in atmospheric dynamics you'd like me to tackle next, and we will break it down.